The last thing that we need to know in order to use the scientific notation properly is the concept of how the base 10 system works. Remember, 10 to the power of 0 represented 1, and each time we moved the place value, it represented a multiplication of 10. So 1 times 10 is 10, and we also learned that because we had 0 base 10s at the time, now that we multiply by 10, we have 1. If we multiply by another 10, we have 10 to the power of 2, or 100, and so forth. So as we increase the value of a number, what we'll notice is that we are multiplying by 10 each time. You may remember how we started off with this chart, and how we showed that multiplying by 10 is the same as writing a power of 10 based off of the amount of times the 10 has been multiplied. Remember, we were counting how many times the decimal point moved in the place value to determine the exponent in the base 10. Because the place value moves 7 times, it tells us that the number 10 million can be rewritten as 10 to the power of 7. So let's try this out with a very large number. The approximate distance between the Earth and the Sun is 93 million miles. We can write this number in scientific notation as a number between 1 and 10, which is 9 3/10, and then multiply the number by the base 10. Now, how do we get it as a base 10? We simply count how many times we move the decimal point from the end of the number to its current location as a number between 1 and 10. So that's 1, 2, 3, 4, 5, 6, 7. So this number is 9 3/10 times 10 to the power of 7. And that's how you write large numbers in scientific notation. For number 11, go ahead and try to do these numbers. Pause the video, and when you're finished, push play to see what the answers are. Okay, so for the first one, how could we write this number in scientific notation? The first thing you want to ask yourself is where to put the decimal point. Because you want the number to be between 1 and 10, you want the decimal point to come after the 9. So count how many place values you would have to move in order to get the decimal point to that location. 1, 2, 3, 4, 5, 6, 7. So this number would be 9 times 10 to the power of 7. The second number, you do the same thing. The decimal point should be between the 3 and the 7. You can count by threes by counting the 3 zeros, or you could count one at a time. 1, 2, 3, 4, 5, 6, 7, 8. So this number would be 3 7/10 times 10 to the power of 8. Let's try the next one. Where would the decimal point need to be? Well, it has to be in between the 1 and 4 to be a number between 1 and 10. So let's go ahead and count. 1, 2, 3, 4, 5. So this number would be 1 46/100 times 10 to the power of 5. Where would the decimal point have to be in the next number? If you guessed directly behind the 8, you are correct. Now we just need to count how many times we would need to move the decimal point in the place values. 1, 2, 3, 4, 5, 6, 7, 8, 9. You need to include all non-zero numbers, and so this number would be 8 4,000 times 10 to the power of 9. All right, let's do the last number there. Where would the decimal point need to be to write this number in scientific notation? Well, the decimal point would have to be in between the 1 and the 7. So let's count to see how many times we would need to move the decimal point. 1, 2, 3. Remember to include all the non-zero numbers, so this number would be 1 75,238 times 10 to the power of 3. And in the next video, we'll learn how to write smaller numbers, less than 1, in scientific notation.